Sysctl functions as a software mechanism in Unix-like operating systems, allowing for the adjustment of system kernel attributes like version number, maximum limits, and security settings. This tool is accessible through a system call for compiled programs and an administrator command for interactive use and scripting. In Linux, sysctl is further presented as a virtual file system. In BSD operating systems, parameters found in the Management Information Base, MIB, serve to define adjustable limits, like shared memory segment sizes, thread quantities for NFS clients, and maximum process capacities. Additionally, they can enable or disable functionalities such as IP forwarding, superuser security restrictions, and debugging outputs. sysctl in OpenBSD and Dragonfly BSD not only handles these tasks, but also acts as the conduit for hardware monitoring within the HW Sensors framework. On the other hand, NetBSD utilizes the IOCTL system call for its sysmin and sys equivalent. Both sysctl and IOCTL play vital roles as system calls, providing a means to extend kernel functionality without necessitating a new system call. An illustrative instance is the integration of the TCP drop utility using sysctl as the foundational system call in OpenBSD 3.6 from 2004. Although FreeBSD lacks a sensors framework, it exposes individual sensors, including temperature readings, via the sysctl tree through NuBus. This sharing of sensors is exemplified by the ABSFR driver present in all 4 BSD systems, including FreeBSD. In the BSD realm, system calls or their wrappers are typically available for program utilization, accompanied by administrative tools and configuration files for adjusting parameters during system startup. This functionality originated in 4.4 BSD, offering the advantage of dynamic parameter adjustments without the need for kernel recompilation. Initially, while kernel variables were modifiable through sysctl, the components of the sysctl tree's MIB were fixed at compile time. Presently, OpenBSD largely maintains this approach, with exceptions like the dynamic subtree management seen in HW.sensors. FreeBSD implemented sysctl internal magic in 1995 for dynamic sysctl tree control, whereas NetBSD adopted its own dynamic sysctl tree implementation in December 2003. The sysctl interface mechanism in Linux is accessible through procfs in the proc sys directory, distinct from -sys. This distinction implies that accessing parameter values entails opening and reading files in a virtual file system, parsing the data, and then closing the file. Despite the presence of the sysctl system call in Linux, it has been deprecated and lacks a wrapper function in glibc. Furthermore, the kernel configuration of many distributions typically excludes config sysctl syscall, rendering the sysctl system call largely unavailable for use. Enabling IP forwarding turns the operating system kernel into a router. In FreeBSD, NetBSD, OpenBSD, Dragonfly BSD, and Darwin Mac OS X, setting the parameter net_inet.ip.forwarding to 1 activates this functionality. Conversely, Linux uses the parameter net.ipv4.diepforward for the same purpose. The command sysctl w parameter shy1 is commonly used in various systems to activate a specific behavior temporarily, valid until the next reboot. For persistent activation during system startups, one can insert or modify the line parameter summer1 in the file at sysctl.conf. Certain sysctl variables are immutable post-boot, necessitating static assignment during kernel compilation or in bootloader.conf, contingent upon the specific variable, BSD version, and variant.